So this question is related to topic spectra, as we discussed the last session about the containers in the line spectrum. The energy level diagram shows the ground state and the two excited states. E1 and E2 are there of a neon atom. In a helium and neon laser, the collision occurs between the helium atom and the neon. This results in the helium neon atom to be excited from the ground state to level E2, and they then emit a photon and move to level E1. So basically what happened, first the atoms are there in the ground state. Like we can explain like ground state here for atom as well, or we can also say for electron. It won't make difference because if electron is excited, we can also say atom is also excited. So first what happened is they absorb energy, collide with each other, and move to E2. And when they fall back from E2 to E1, it releases energy in the form of packet or a photon, which is equals to the difference in energy of the two levels. So this result in a helium neon atom being excited from a ground state level to level E2, and then they emit a photon and move to level E1. What is meant by the energy level? So first, the definition of energy level. Basically, like how we define energy level. Energy level is a region where like allowed or possible energy of atom is there, or for electron in an atom is there. So energy level refers to, like if they ask define energy level, then you will mention allowed or possible energy of an atom or electron in an atom, the space or a region. Electron in an atom, that is refers to energy level. Then what is a photon? How we define a photon? Photon is basically a packet of energy or a particle of a light. So what is photon definition? It's a packet of energy, or you can also say it is a particle of light. Then write the formula in terms of E1 and E2 for energy of an emitted photon. So if we need energy of the emitted photon, because the electron will jump from higher to lower, so the energy of emitted photon will be equals to say E, and that is equivalent to difference in energy of the two levels, which is E2 minus E1. Then the wavelength of the emitted photon is 6.33 exponent minus 7 meters. Calculate the energy of the photon. So how we can calculate the energy of this photon? We have the formula E is equals to HF, or E is equals to HC over lambda. E is equals to HF is valid if we know the frequency, but E is equals to HC over lambda is valid if we know the wavelength, because frequency is speed divided by wavelength. So separately, you can work out the frequency by speed divided by wavelength and then substitute in the formula E equals HF, or you can directly use this formula HC over lambda to get the final answer, where H is a Planck's constant, C is the speed of electromagnetic radiation, which is 3 exponent 8, and the wavelength is given in the question, which is 6.33 exponent minus 7. So just we have to substitute these values. E equals H, which is 6.63 into 10 to the power minus 34. C, which is 3 into 10 to the power 8. And lambda, so lambda is given in the question, which is 6.33 into 10 to the power minus 7. So when we substitute, this will give us the energy. So to get the energy, E is equals to hc over lambda. So h is a Planck's constant 6.63 into 10 power minus 34. C is the speed of electromagnetic radiation, and lambda is the wavelength 6.33 into 10 power minus 7. When we substitute, this will give us the final answer. For the energy which is emitted from this photon. Which is 3.14 exponent minus 19 joules. Then in question 6, the diagram shows the main component of a fluorescent light tube. There are electrode, mercury vapors are there, phosphorus coating is there, and the two electrodes and the glass tube. When the light is switched on, the charge flow between the electrodes and the mercury atom becomes excited. This is actually, maybe you have seen the mercury lamps. That's how mercury lamps are working. Like there are mercury vapors or mercury atoms are there. So when we switch on, the electron actually move from negative electrode to the positive electrode, but in the way these electrons collide with the atoms. And when these electrons, as they're traveling from one electrode to another, collide with the atom, so these electrons transfer their energy. And when these electrons transfer the energy, so inside the mercury, for a mercury atom, which also consists of a nucleus, and there are regions, energy levels are there. So basically, like in a microscopic level, what happened? That the moving electron, the electron which is moving may collide with an atom or may collide with an electron which is inside the mercury atom, and it will transfer that energy. So this causes the electron to jump from one shell to another. And when this electron jumps from one shell to another, it cannot remain there for a longer period of time. As a result, when it returns back to the same ground state, it will release a photon which is equals to the difference in energy of the two levels. That's how the mercury lamps or a fluorescent lamps are working. So when the light is switched on, the charge will flow between the electrode and the mercury atom become excited. Like what is the meaning of mercury atom become excited? Means the mercury atoms absorb energy. And the mercury atom then emits electromagnetic radiation as specific photon is emitted out from these mercury atoms. So the question is, what is meant by mercury atom being excited? So definition for atom being excited, that atom being excited means atom or electron gain energy and these electron move to higher energy states. So the term excited means that atom or electron gain energy. That's one thing. That's one mark. And then electron or atom you can also mention, because there are like energy states for atoms as well. So electron jumps to higher energy level. That is the meaning of atom being excited. Explain how the excited atom emit radiation. So the second part, atom is being excited, but how it will emit out radiation or give out radiation. So what happened when this electron will, like in a higher level, move to lower level, or electron or atom moves down from a higher level to lower level, it emit a photon or it emit a particle which is having energy equal to the difference of energy of two levels. So electron jump back to lower energy level. electron release a particle or photon, you can say, and the energy of the emitted photon is equals to difference in the energy of the two levels. So E2 minus E1. Explain why only certain frequencies of radiations are emitted. Like, why not like 2 joules, 2.5, 2.3, 2.1, any, like not range of energy is emitted. Why specific energy is emitted? So the reason is because like energy level does not exist as all the, it's like there are no regions or energy levels are not at all the regions. There are specific regions or atoms or electron exist in a certain energy level. So or only certain energy changes are possible. Like not all the energies are possible or energy changes are possible. Say if you have a mercury atom, so if we have a mercury atom, so this is a nucleus, and then there are 7 shells, which is K. Then we have L, M, N, O, P, and Q. So these shells are having a definite distance or a gap. Like it's not like electron can be anywhere within an atom. Electron is at a specific like a place or a region within an atom. So, and when this electron will move, so electron cannot be anywhere within an atom. It's a specific look, position is there or a specific place for the electron where we can find it. And that electron, when it jumps from one shell to another, only specific amount of energy can be released. Not all the energy can be released. So the answer, when you write an answer, you will mention electron are existing or electron exists in a certain or specific energy levels. And only certain energy changes are possible because like if electron jump from this shell to other or jump from fourth shell, jump from fifth shell to first. So specific energies can be emitted out, not all the energies. And the energy which is emitted out depends on the frequency or the wavelength of the radiation. So the answer for this one, that these electrons exist in certain specific energy levels. Then only certain energy or specific energy changes are possible. And the energy of the photon depends on the frequency or the gap between the levels. Like if electron jump, like for example, if electron jump from last shell to first shell, there's a greater gap, so more energy is released as compared to electron jump from third shell to the first shell. Is it clear, this one? Why specific frequencies of radiation are emitted? And the last ones, some of the radiation is ultraviolet radiation, which is which the human eye cannot detect. The phosphorus coating absorbs the ultraviolet radiation. So there is a coating of the phosphorus